Okay, hello, and welcome to a showcase of my most recent project, which is a road detection and segmentation model, which I believe can be a component of a much larger autonomous self-driving system, which can be used by vehicles. Now, the system focuses on the perception side of things, helping the system understand what it is looking at and help it in making a decision of whether it should move forward or not. Simply put, it focuses on answering a crucial question, which is, am I looking at a road or not? If yes, how much of it is the road and how much of it isn't? Now, the original goal was quite simple. It was to train a model that can classify each part of an image into road or non-road images. But then I realized that segmenting every single input frame was not going to be very efficient. There needed to be a higher overview or a higher level decision that had to be made at the very beginning to even decide whether this input frame should be segmented or not. And the solution to this problem was a pipeline that assesses the necessity of segmentation. Only then, in case of a positive road frame, it moves forward to the task of the actual road and non-road pixel classification. And this is the two-stage pipeline that I landed at to solve this issue of we don't need to segment every single input frame. Now, the first model or the first layer of this model is an autoencoder which decides if the scene should be segmented or not. Simply put, this is the layer of the model that decides, am I looking at a road or am I looking at, for example, a river? If I'm looking at a river, I don't need to pass this further to the second layer because a car cannot drive on a river anyway. And the second layer of the model is what takes care of the actual pixel and pixel level classification, telling the image which part of it is the road and which part of it isn't. And that was done using a modified unit. Now, during the development of the first layer of the model, which is the one class classification to decide whether I'm looking at a road or I'm not, it was actually an iterative approach, which started off with me working with a convolutional neural network, then moving on to a one class SVM, and finally landing at my solution, which is the autoencoder, as I already mentioned on the previous slide. Looking at why the CNN didn't work out for me is it's easy to gather images that qualify as a road, but trying to teach my model what isn't a road quickly became a tedious task because what qualifies as not a road, the possibilities of that are endless, and it is just not feasible to gather that many images. The model would not be able to generalize both of those classes very well. And hence, I had to drop the idea of using a CNN for this task. I then moved on to the one class SVM. Now, this solved the initial problem from the CNN stage where I no longer need to tell the model what doesn't qualify as a road because all I needed was to tell the model this is what a road looks like, learn these features, and tell me whether I'm looking at a road or not. But then I faced an issue on this stage as well in the form of the model being too strict, meaning that for multiple instances of a clearly looking road frame, the model still rejected it and it was not able to be passed on to my segmentation model. Even valid road scenes were not classified as a positive frame. And hence, I had to find another solution. Now, the solution came when I shifted my view from looking at the first task as a classification problem to an anomaly detection problem. Once I made this shift, I was able to open up a few more solutions that are available to me. And one of them, which did work out for me, was the autoencoder model, which provided the right balance that I was looking for, meaning it wasn't very strict at telling me what is a road, whether I'm looking at a road or not. But at the same time, it was also providing the exact results I needed, meaning it was not classifying incorrect images to be a road and too many input road images as not a road. So I used road images to teach the model what a road looks like, and it was able to generalize much better compared to the other two models that I used. And most of it came from the fact that I could tweak the reconstruction error by myself. I was able to tweak it and change it to a little less strict value so that I could pass more of the actual input road frames as a green light to be segmented by the second layer of my model. And finally, the actual segmentation task was taken care of by the modified unit. Now, the model implementation was somewhat straightforward at this stage, but most of my work in this phase came from preparing the data for training this model. I needed a data set which provided me original images of what a road looks like with vehicles and fire hydrants and people, but at the same time, I also needed masks to be able to train the model. Now, the dataset that I was able to get my hands on is the Cityscapes dataset, which did provide me in exactly what I needed, but it gave me masks of not just road and non-road, but it also classified other objects in the image, like a car or a human or a pole. But what I needed specifically was just purely road and non road. So I had to do some processing on my end before providing it to the model. Basically, had to remap anything that is not a road to completely non road to be able to tell the model that it needs to learn only two types of objects, a road pixel and a non road pixel, where the road is marked with white and the non-road is marked with black. Now let's move on to a demo of the project. Just a second. Yes. You can go and try it out for yourself from this link here. I will also add it to the caption of the post. Now, let's pick one of these images. First, let's start off with a video that clearly is not a road. Now, the video is going to be processed and each frame is going to be displayed as it is being processed by the model. And you can see that clearly we are not looking at a road. And the model realizes that, and this is the autoencoder rejecting the input frame like, hey, this doesn't need to move on to the image segmentation model. We should immediately stop right now. We should not move further than we already have reached. And let's look at an example of an input video where we are in fact on the road. And as you can see, the input image for the autoencoder satisfies the threshold value. The model realizes that I am indeed looking at a road. Let's pass this on to the next model, which is the unit, which is currently classifying. And you can see that the output is overlaid. I have overlaid the actual input frame as well as the output frame from the processing and just made it a bit transparent so you can see that the road pixels are being classified as a black color, whereas the non-road pixels are being classified as a white pixel. So there are a few improvements that I can make still on this project. One of them being the time taken can be still improved because as you could see, it was a bit slow. The processing was a bit slow. The edge cases can be developed or dealt with to improve the robustness of the model. And as I already mentioned, the inference time can be optimized. But overall, I believe this project and this prototype at this stage is able to clearly convey the idea that I'm trying to portray, the system that I'm trying to build. And yeah, thank you.